Hey all, hope everything's going well with your robotic stuff. So I just want to keep you up to date. You are expected to have gone through this and done all the work for it, so you should be right on track. The first half of class is going to be working through these examples that I do with everybody, and then the second half is working on the review for the test. So let's go ahead and jump into it. If you hear anything in the background, it's either my daughter making noise or it's my dog, so I apologize now, but hopefully you can hear me. All right, so we've got two things that are in trig form. And we're going to find the product of it first and talk about how to do that, and then we'll do the quotient. So if Z1 is R1 cosine theta sine theta, Z2 is R sub 2, excuse me, cosine beta, I sine beta, so we can abbreviate that if you'd like to. You don't have to. I have it in the last lesson. So what we're essentially going to do is take the two values up front, the two R values, so R1 and R2, and we're going to multiply them together. And then condensing everything together, it'll be the CIS of theta plus the alpha there. Okay, so that's what we do with our two angles and everything in order to multiply our two complex numbers while they're in trig form. Okay, so if you multiplied complex numbers not in trig form, then it's going to be the normal multiplication, which you would just FOIL everything out. But we're talking about how do we do it when it's in trig form. All right, so same thing with the dividing. So we saw the dividing in trig, the complex form in last class, or in when we reviewed everything. So now how to do it in trig form. So essentially what you're going to do is take the R values and divide them. Order matters. So R1 over R2 because it's Z1 over Z2. And the difference here is we're going to now subtract the angles. So for multiplication, you're going to multiply the R values, add the angles, and then when you're dividing, you're going to divide the R values and subtract the angles. Okay, so I'm going to do one of each for you, okay, where I'll do one with multiplying, one with dividing, and then do something else. Okay, all right, so the first one we're going to do here is z sub 1 is 2 cosine 120. The second one is z sub 2, 8 cosine 330. So what we're going to do is give answers in both trig form and standard form. Okay, so the first thing we're going to do is set it up. So what we'll do is first take the two R values and multiply them together, so the 2 times the 8. Then from there, we're going to add the two angles together, so the 120 and the 330. And what we'll go ahead and do is kind of simplify things. So 2 plus 8 is 16. The 120 plus 330 is 450. Please try to keep your degrees or radians from either 0 to 360 or 0 to 2 pi. So 450 degrees, if we were to go around, is in the same spot as 90 degrees. So this is our trig form answer. If I said, okay, give it to me in trig form, then you'd be done. And then we went over in the last lesson how to go from trig form into our standard form of a complex number. So we're going to go ahead and re-expand the CIS to give us cosine 90 plus I sine 90, and then we'll evaluate. Cosine 90 is 0, sine 90 is 1, and then distribute. So in the end, we end up with 16I as our standard form, which is our standard form answer. So that would be the final answer if I asked you for standard form. Okay? All right, so then for the division, it's just as simple. So we're going to take the 24 and divide it by 8 because we do Z1 divided by Z2. We divide the R values, and then we're going to subtract the angles. So we'll do 300 degrees minus the 75 degrees. So when you subtract, you get 225. It's between 0 and 360, so we're good. And the 24 divided by 8 is 3. So this is your trig form answer. Let's go ahead and expand it now so we can switch it into standard form. So what we end up with is cosine 225 plus I sine 225. I don't know what I did there. I'm very sorry. Sorry about that. Like I said, that should be a plus right here. But sine of 225 is a negative answer anyway, so it's negative square root of 2 over 2. Cosine of 225 is negative square root of 2 over 2 as well. And then we can distribute 2 with the 3. So our final answer here would be negative 3 square root of 2 over 2 minus 3 square root of 2 over 2i. Or you can have negative 3 square root of 2 over 2 plus negative 3 square root of 2 over 2i. Either one of those answers is fine. So again, my bad here. This should be a plus sign. Okay, so those are the main two things that you would be learning in class, and then you would do some practice examples on this. That's your standard form and your trig form. So the third thing we're going to do is to use polar form or your trig form to find product or quotient, and it's going to be given to you as a complex number. So the first thing you have to do, if we're going to be doing everything using polar form or trig form, is we're first going to convert. then apply the operation that we're dealing with, and then convert your answers to the correct form. So when we're converting to our trig forms, I'm assuming that you picked up on that lesson from last block. So I'm going to kind of skip some steps of that just to save some time for this video for you. So if I give it to you like this, so 2 minus 2i times negative 3 plus 3i, the first thing we're going to go ahead and do is convert that into trig form. So in class, I would go through and show you, okay, well, 2 minus 2i is found down here in the fourth quadrant, and then negative 3 plus 3i is found here in the second quadrant. And what you'll need to do is find what is r, and you also need to find what theta is. So again, that all follows from the last lesson that we had just did. So what we end up with is one of the angles is 7 pi over 4, and the other angle here is 3 pi over 4. And then the radius, or the r value, for the first one is 2 square root of 2, and for the second one is 3 squared root of 2. So you should be able to get those, no real problem there. You can also see that it's got like a 45, 45, 90 kind of vibe to it when the two numbers are the same there. Okay, so again, just make sure that these angles are in the correct quadrant. So 2 minus 2i is found down here, so we know we're in the right stuff. And negative 3 plus 3i is found in quadrant 2, so we know 3 pi over 4 is correct. And then from there, we can go ahead and combine our like terms and multiply out the front. So 2 times the square root of 2 square root of 2 times 3 square root of 2 is 12. If we add the pi over 4s, we get 10 pi over 4, but again, we want to get it so that it's in the same it reduces down to 5 pi over 2. We want to get between 0 and 2 pi, so that is coterminal with pi over 2. So this is our trig form, but I did want it in trig form and in standard form, or in the standard form there, so we can go ahead and expand that. So this is 12 times cosine pi over 2 plus I sine pi over 2. Again, we can evaluate those to get 0 plus 1i, and that gives us 12i. So I know I went through that a little bit fast. Okay, but this step number one here is something that we did in our last block, so you should be okay with doing that and converting these standard forms into our trig form. Then we take the two trig forms and multiply them together, hence what we're doing in step number 2 here. And then this is our trig form of everything. We're going to expand it now to do complex forms. That's kind of the idea behind it. Again, a lot of this is carrying over from last lesson. The new part of this is the multiplication and the adding of the angles together. Okay. All right, last thing. So this is on the very back of the packet there, is kind of deriving some information. So if I were to give you this, say here, number 1, if I were to ask you to simplify that, since it's a product, we can distribute the 2 over here, getting 2 to the second power. And then if I were to FOIL this out, what we end up with is 2 squared times CIS 60. Now we're not going to do, we're not going to actually FOIL it out. Sorry, we're going to use what we just went over. So it's essentially doing 2 CIS 30 times 2 CIS 30 and putting those together. And we end up with 2 squared the CIS 60 degrees. So then if I continue doing that process there, so if I did it to the third power, it would be doing this times itself 3 times. Again, using the quote product stuff that we were just talking about. So it would be 2 times 2 times 2, and then there would be 3 of these angles of 30 degrees added together to get 90. And then continuing on, if I did it with 4, okay, sorry about that. So we're going to take the 4 and do the multiply by itself 4 times. So this would be 2 to the 4th, because 2 times 2 times 2 times 2 is 2 to the 4th. And then we're going to be multiplying this times itself 4 times. Remember, we add the angles. So we'll do 30 times 4, which is 120. So we can do the exact same idea with the 20. So hopefully you're picking up on a pattern here. Essentially, this is going to become the exponent for the 2. So you're 2 to the 20th. And then all these angles, since they're multiplying by itself, we're essentially doing 30, adding itself 20 times. So that's why we can do 30 degrees times 20, or 600 degrees. So in the end, our R value is always going to be to the power of n, whatever this value is on the outside. And the angle is always going to be multiplied by that n value, or what's on the outside here. And that's what this theorem is here, De Moivre's theorem. Sorry, I'm going to look at how to say that before class. Sorry about that. But if we are taking the same thing and putting it to the nth power, we're essentially taking r times cosine plus I sine theta to the nth power, and we can simplify this down further to represent this. We can also see it with the CIS instead of the cosine plus I sine theta. The exact same idea. We would do r to the nth power, and then we would multiply theta times n. So I'm going to do one example with you. So we have the square root of 3 minus I to the 4th power. What we can do is convert that first to trig form. So again, same as previous. So why don't you take a moment to do that now? Okay. So take the moment, hit pause to convert it to trig form. If you do, you should get 2 CIS 11 pi over 6 when you do convert it. All right, so now we're going to take that and put it to the fourth power. So using the theorem that we just discussed, we're going to do 2 to the fourth, and then we're going to take 11 pi over 6 and times it by 4. So when we get that, we get, and to simplify it down, we get 2 pi over 6. 2 to the fourth power is 16. 11 times 4 is 44 over 6, reduces down to 22 pi over 3. But again, we want it between 0 and 2 pi. So 22 pi over 3 is in the same, is coterminal with 4 pi over 3. So this would be everything in trig form if I were to convert that way. Now, if I asked for standard form, then that's when we're going to expand, we would evaluate, and then we would distribute, and that would be your final answer. Okay, so those are the examples that you can use to now complete the rest of the packet. And then from there, we have the um, review packet for you to work on. So take a look at all that. If you have any questions, please again shoot me a message, feel free. And hopefully I will see you all on Monday. Have a wonderful time on your robotics trip. I hope everything goes really well. Take care.